Hello, and thank you for listening to this presentation on the Lake Eyre Basin seismic deployment. Here we'll be using an AuScope funded array to investigate relationships between seismicity, minerals, and craton margins. The work I'll be presenting today is in large part reflecting the work of Shubham Agarwal, who's currently conducting his PhD on this new data set at ANU. We'll also have contributions from JP O'Donnell from the Geological Survey of South Australia, who is currently leading the AusArray SA. The Lake Eyre array is represented here by these yellow symbols encircling Katitandiu Lake Eyre in Central Australia. To the south in white, we have the AusArray SA, and together these two deployments are giving us more information about the eastern margin of the Gawler Craton. Many of these sites are located in remote areas of Australia, including across the Simpson Desert, which we were only able to access using helicopters. This is a really interesting region, not only because it's a craton margin, but along this boundary, there is significant seismicity or intraplate seismicity. And in 1941, there was a magnitude 6.4 earthquake here in the Simpson Desert, which we know very little about given its remoteness. Across this region, there's also significant mineral resources. Represented in green here is the distribution of known copper. As well, there are several significant mines, including Olympic Dam and Prominent Hill. So using this data set, the goal is to undertake different seismic analyses to learn more about the subsurface and the nature of the margin of the Eastern Gawler Craton. In large part, this work is funded by my current ARC DECRA. So we'll be looking at the local seismicity, sedimentary thickness, seismic tomography, Moho, and seismic anisotropy. So I'll start by sharing some initial results. If we start with the seismicity, then this would be a map of what we would currently know about the region if we didn't have this array. So the black dots represent the historical seismicity from the GA catalogue, and the white circles are the events recorded by GA that happened during the time frame of the Lake Eyre deployment. Shubham, as part of his PhD, has been using the new data from the Lake Eyre seismic array to detect and locate local seismicity in this region, which is represented by the red circles, scaled by the magnitude. Shubham has been able to detect 77 new events during this time frame. And we find that they seem to follow a more linear pattern throughout the region of historical seismicity, indicating a more narrow region along this eastern boundary. Around a third of the events are associated down here with this cluster, and this lies right on top of Prominent Hill, so we think that that's related to mining activity in the area. Shubham has also been doing some really fantastic work using receiver functions to determine the sedimentary thickness or the basement depth beneath and across South Australia. So this is using the time delay between the first arrival on the vertical receiver function compared to that on the radial receiver function, with the time delay pattern shown here on the right. This is work that's currently in review at BSSA, and Shubham has recorded a full presentation, so do check that out too. He was able to calibrate this time delay with the known basement depth from borehole measurements to create this map showing the basement depth across South Australia. Meanwhile, JP O'Donnell at the Geological Survey of South Australia has been using the combined Lake Eyre and AusArray SA datasets to look at Rayleigh wave phase velocities using ambient noise. He's been able to recover phase velocities for periods of 2.5 seconds down to 25 seconds. And you can kind of equate, rule of thumb, the period to the depth. So 2.5 seconds would be 2.5 kilometers. He's hoping to be able to add earthquake data to this to extend down to periods of 120 seconds. And what he's finding, particularly at the shorter periods representing the shallower depths, is that the slow velocities correlate very well. In red here, the slow velocities correlate very well with the sedimentary packages. And they also have excellent correlation with Shubham's results from the receiver functions that I showed on the previous slide. Another interesting feature of this region is the Moho. Here I'm showing a map of the Moho model updated last year by Salmon et al. And in the Lake Eyre Basin region, we have predicted some of the thinnest crust in Australia, or the shallowest Moho, with depths of 25 kilometers or less, although there's very few measurements that have been made in this region with only a couple of symbols. And right juxtaposed next to it is some of the thickest crust, or the deepest Moho, of up 35, 40, 45 kilometers beneath central Australian provinces. So we're interested to see if we can find out more about this transition from this deeper to shallower Moho within this region. Shobham's been looking at the receiver functions to try to see if he can find the Moho, but it's been pretty difficult so far. Having the thick sediments, particularly in the northeast part of South Australia, induces a lot of ringing onto the receiver functions. But there are some early indications if we look at this profile B to B prime here and look at this feature, there are some indications that there is a deepening discontinuity, which could be the Moho. However, this is going to require further analysis to try to characterize the Moho across this region. And lastly, I'd just like to share some recent results from seismic anisotropy, looking at the patterns across the Australian continent. Here I'm showing results of SKS splitting along the Bilby Array, which was a linear transect of 25 stations from north to south across central Australia that operated from 2008 to 2011. And this is work that's currently in revision at Tectonic Physics, and hopefully will be out soon. And what we find is that the fast directions, the fast anisotropic directions in this region were commonly coming out as being orientated east-west. So that's the orientation of these red bars. And they correspond very nicely to the geometry and orientation of the different crustal blocks and geological provinces in this region, as well as the prominent gravity and magnetic anomalies. And we've interpreted this, that the shear wave splitting is reflecting a record of ancient lithospheric deformation that has been preserved within the Australian lithosphere within this region, rather than reflecting the strong mantle flow in the asthenosphere due to the shear of the plate motion of Australia. We've also had work recently published in Communications, Earth and Environment using scattered surface waves called quasi-love waves that tell us about lateral gradients in seismic anisotropy at upper mantle depths, most likely between 100 to 200 kilometers. In yellow are the detections of these anisotropic gradients that correspond to the geological provinces. And as you can see, many of these locations of these gradients correspond to the edges of the different Archean and Proterozoic crustal blocks within Australia, the building blocks of the continent. We also have many gradients, anisotropic gradients detected along the passive continental margins highlighted here in cyan, including prominent anomalies along the edge of Zealandia and Eastern Australia on either side of the Tasman Sea. So we've interpreted these results as reflecting that the Australian lithosphere preserves frozen in anisotropy that reflects past deformation, particularly from continental assembly, potentially preserved over billions of years. And that those gradients that have been detected in seismic anisotropy beneath the passive margins are more likely reflective of a flow within the asthenosphere, and potentially this is due to either a step in the lithospheric thickness or a difference in the properties between the oceanic and continental lithosphere that induces some kind of modification or disruption to the mantle flow below, potentially in the form of edge-driven convection. So that's it. Do stay tuned for further updates in the future we've still got more data to come from the Lake Eyre Basin seismic deployment. Thank you.